Hi students, today we're going to talk about price projection. When we say price projection, we also mean revenue projection, income projection, cost projection, return projection, uh, war projection, if you want to go to this. So forecast, any forecast you want to do, this is what we're going to talk about it. So obviously this, we use it a lot in applied economics for revenue projection, income projection, but in behavioral finance, we use it for price or return projection. Uh, in accounting, we can do it for other cash flow projection and other things. So we can use that for different fields. There are two models that interest us. One is called Monte Carlo model for projection, and one is a Markov process. So one is a Monte Carlo simulation, and one is a Markov process, Markov chain or leapfrog model. So what's the difference between the two? The two is simple. The Monte Carlo simulation, to help you to project the future price, uh, it assumes that random walk. Random walk means that the price of today or the revenue of today or the income of today or the cost of today does not influence the future price or revenue or cost. That's a Monte Carlo. So random walk, whatever is the price today, tomorrow, it has nothing to do with today. The other one is the price of today influence the future. So for example, if you heard about the momentum theory, momentum in the stock market, this stock has a momentum. So it's going up, going more up, continue going up, or going down, continue going down. Means that the price of today or the revenue of today or the cost of today or income of today influence the future. So you maybe think intuitively that um, why you to use Monte Carlo? It's not a random walk. It is a random walk. Random walk is a lot of processes are random walk, especially in the short term. Like if you look to the daily prices of stocks or oil and gas or this that trade every day, there are random walk every day. Yes, if you look the monthly, they're not, but in the daily, probably random walk. So, so we're gonna do projection with random walk, Monte Carlo. We're gonna do projection with the leapfrog, and then we can or Markov chain, and then we're gonna decide which one to use. Now, in a professional life, I didn't do both of them. I can do the screen, and from the screen, I know which one, Monte Carlo or leapfrog. And by the end of the video, you will also learn how to do the screening and to choose a model. But because it's a class and we education, we need to teach you both, and then we do, then you decide which one. So let's go with the Monte Carlo. Monte Carlo is, by the way, it's a good place in France, and it's by a French scientist. He did that, and it talk about random walk, IID, identity distributed distribution, and the idea is the tomorrow price follow a drift and a random value. And this is the formula, and this is the mathematical equation. So the idea here is that the price of today, it has nothing to do with tomorrow, and tomorrow is a random walk, but it will walk through a distribution. And what we need to know is to learn what is this distribution, how to walk. And then the other model, Markov process, probably you heard about it, but if not, it assumes, for example, two states. In my real world, I do 4 states or 5 states. But for this class, to make it simple and doable in Excel, we're going to do it in 2 states. So we can say, for example, high and low, like the revenue is high this quarter or low. And then you can say, what's the probability next quarter will be also high? Or if it's high today, what's the probability is going to go low? So we need to create a probability matrix. Suppose it's high, so the probability to go high again, it's alpha. The probability it's high and going next period to be low, the probability will be 1 minus alpha. And the probability if I am low going to high is 1 minus beta. And the probability that I am low and going to low again, it's beta. So how to calculate, and then from this, you can see what is going to be the prices. So we're going to take example, we're going to take Amazon as an example. Before I go there, I want to say that if you go to your canvas, you will see something called empirical forecast. And there are four things here, which is a Markov chain document, Monte Carlo document. You will see my video, and you will see a price projection Excel file. So I want you to open all the four and watch the video. Basically, I want you to open the video, open all the four, and then watch the video and interact with the other documents. So I'm gonna start with with the Excel. So in Excel, you're gonna have a Monte Carlo, regression output, leapfrog, and data. So we need to find a company or something to project empiricals and to and to do some work on it. So I'm gonna choose, actually, you can choose any company basically. I'm gonna choose maybe Amazon. So I'm going here to Amazon. So I went to Yahoo Finance. I got Amazon from there. And you go to historical prices. And then you can see here, you can go daily, weekly, monthly. For today, I'm going to use monthly. And then I'm going to go basically full year. Well, that's good. I'm going to do apply. And then I'm going to go download. And then I got the data about Amazon. So now I need to calculate the change. In this case, it's a return. So the return is equal of Amazon is this minus this divided by this. The price of today minus the price of last period divided by the price of last period with the parentheses. And then double click the last one, the last observation. You didn't need it. You have all the observation. Sorry, you need all the observation. And then a distribution. I need 2 moments of distribution. There are many moments for any distribution. This is, we call it distribution. All of these numbers, the history of return for Amazon, month by month, is a distribution. This is one observation and distribution. That's the second observation. We have probably 12. So you need to calculate the mean and the standard deviation. The first moment is the mean. The second moment is standard deviation. And then you just go function, average, okay. And you say what's the average of this distribution. Okay, okay. And then you do the standard deviation. And you say what's the standard deviation of this distribution. And enter. Okay, done. So this is a distribution for Amazon return, stock return. And these are the 2 key moments that we're working on. There are many moments for distribution. The third one is skewness probably. Now, if you want to do a projection for the revenue, so basically you will have a revenue here, revenue here, revenue here, revenue here, and then you calculate the change in revenue or the revenue growth. So if it's a revenue, you'd say revenue growth rate, and you just calculate the same as I did here in the return. If you have a cost and you want to project the cost, you just do the cost growth rate, and then you do the same. Here I calculate the return. So again, you do that in every science. Monte Carlo is not only for economics or finance. In all science, physics, mathematics, everything. Actually, it came from mathematics, not from science, economics, or finance. We use it. So cost projection, you just do the growth. Revenue projection, you do the growth. Okay, that's it. I got these 2 numbers. So these 2 numbers give me all the information about Amazon. Everything I need to know about Amazon is here. All the information from shipment, number of people in a company, cost, revenue, projection for revenue, projection for all the information, all the activities of Amazon is here. Now you know all the information. Can you believe it? In one sequence here, you got all the information. These 2 moments summarize all of this information. I'm gonna copy these 2 numbers. I'm gonna copy the entire file actually. copy, and then I'm gonna go here. So I have I did that. So let's see what I can get. All right, so I got them here. So now you get the data. All what you need is 2 moments. Copy these 2 moments and go to the file called Monte Carlo simulation. You do right click and put pass. Now you get the numbers and you get the simulation. What are you doing here? Basically, you put the mean and standard deviation and you say, listen, the price is moving random walk, but there's a 2 moments that the price going through them. On average, the price does 0.0067 a monthly return, and the standard deviation is 0.06 at the monthly level. So this is a distribution. The price going random, but for a defined distribution. And this is a defined distribution. So the monthly performance basically is, so what you need to do after you put these 2 numbers, the simulation, I created for you a simulation here of about 1,000 simulation here. You see here, you have 1,000. That means, let me put it in yellow. This is a number of simulation. You can make it 5,000. It's up to you. So that's a free country, how much you want to do it. So all what you put here and you're done, basically, the simulation. So every one simulation he show, there's a case, the price can go negative 9%. There's a case, the price can go up 2.1. So how I did that, what you go, you do something called data, what if, this, and you choose data table. You click here, you choose any cell, you click here, you do OK. You choose any cell, you do OK. And that will give you the simulation. Here is a simulation that you will get. So what if, table, you choose the second one, you choose this any cell, and OK. And then that's a simulation. What if, OK. Oh, sorry, I did forget to do something. What if this, cancel. What if you choose any cell, OK. That's it. Now you get the simulation. I'll do it again. You do this too. You go what if, data table, choose any cell, OK, and that's a simulation. We're done. Now, so you want to do 20,000, then you go, I did 1,000. You want to do 2,000, go down, scroll down, and then when you do the simulation, choose the 2,000. Now the analysis starts. So you can ask, for example, what's a chance that Amazon next month will go above the return 0.01, like 1%. So that's a chance, 47%. What's the chance going to be 7%? Well, the chance is 5%, 15.4%. That Amazon next month is going to go 7%. So the chance is less. What if you want to do something like the chance that Amazon going between 1 and 2%? Well, what you do is, what's the chance to be above 1 versus the chance to be above 2, which is I did it here. And the difference will be the chance to be between 1 and 2 next month. So there's many ways how to calculate the distribution. So all I want you to do in your presentation is pick a company, collect the data, get the 2-moment distribution, put this 2 moments distribution here, do the simulation with what if, and then just show me in the video some simulation. You want to have 1%, I put 1% and 2%, but you can do 6%, 7%. What's the chance between 8 and 15%? Anything you want to do. So this is give you the probabilities for every aspect. For example, if you expect the stock market to go 10%, the monthly level 0.8, then you can ask what's the chance that next month we're going to beat the S&P average, what expected return, which is 0.08. So what's the chance we're going to beat the S&P? Amazon is going to beat the S&P. Then it's a chance of this, 48% 3, we're going to beat the S&P next month, or Amazon will beat the S&P next month. If we assume the S&P is going to do 10% and annually, which is 0.8 monthly. You're done. So now we're going to go to the other story. What if it's around, I mean, not random walk, it's dependent, but the price of today influence the price of tomorrow. We call that serially correlated. Like there is correlation between where you're going from today, tomorrow, to Tuesday, and Friday, whatever is it next day. There's a correlation. You're not going in a random walk. You're going through a process. So this is work more into larger period, not in a daily, larger period. This is more a good model. So this is the model. What you need to do to solve this model is to get the probabilities alpha and betas. And you need to get the R down, R up, alpha and beta. So these are the moments that you need to calculate them. Once you calculate them, then you can see the price next period, or the revenue next period, or revenue growth next period, income growth, whatever quantity you want to do. So we're going to go to Excel again. And then we're going to take the data about Amazon and do a copy. Sorry, that's Excel. We're going to go to this Excel, go to the data, pick the data about Amazon, do a copy. So we have all the information about Amazon. And then we're going to assume, hey, we believe in not in a random walk. We believe in a serially correlated model. We put the data here as you can see here. You go here, right click, and values. Right click and values. And then that will be 12. No, 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 no. That will be, sorry, 12. Okay. So that's the last observation I needed. So this is RT. I need to calculate something called RT minus 1. So what's our RT minus 1? So RT, like if the return today is this is a return, the question is, what's the future return? What's the lag return? The lag means the previous one. Well, the previous one is 0.08. If this is the return today, what's the previous one? Well, this is the previous one. So what we do, we copy those, copy, and then we paste them here. Right click. Now this is going to be RT, and this is going to be RT minus 1. So now to get the model that we need, basically we need to regress RT over RT minus 1. And then we need the three quantities, the yellow and the red and the green. The yellow is a constant. The rho is a serial correlation, the relationship between T minus 1 and T. And the epsilon is the innovation term, we call it. So we need to regress RT over RT minus 1 and get these three quantities in our model. So that's what we're going to do now. We're going to regress. This is RT, this is RT minus 1. We're going to regress them and use the quantity. So how to do that? You go data. You see data analysis here. So I'm going to take it off. Options. Add-ins. Go. So you see this. If you uncheck these boxes, this is going to go data analysis. Let me uncheck them and go again. So I need something called data analysis. So the way to get to add data analysis, you go to option, file, option, add-ins, go. So click this, check this box, great. And then you get data analysis. You click in data analysis, you choose something called regression. That's a regression. You do OK. And then what is your Y? Again, here's the Y. That's your Y, and that's your X. You have one X and one Y. This is the Y. This is the X. So the Y is RT. You see, I added RT here. And then I have to check labels because I added the first one. And the X is this. And OK. So now this is the constant. I'm going to put it the yellow. And this is the red. And then you have this one. So So there are, so okay, I'm gonna put in the green. But here's where students do the mistakes. I need these three numbers, this number, and this number. We're done. It's just now we're gonna read the results. You put them in a leapfrog. You put the yellow here, the red here. Now the green is here. Now the green, it's a square root of regression output. Not, so what students do is they take this number and they put it here. And then the results are, doesn't make sense. You need to do the square root. So I put for you square root regression output. So what you need to do is you take this one, you do delete, you go to the sheet, and you click on that and you do enter. That's it. So now what you have, the square root of that one, the sheet basically. All right. And then the yellow is yellow. So you go here, that's a yellow. So that's equal, there is no square root or anything. Just take the yellow. And then the red equal, excuse me, the red equal to the red, and enter. And that's it. We're done. We're done. So now I'm going to read the results, but we're done basically. So what Joseph, that means we're done. Again, what we need the four things: R down, R up, alpha, and beta. So what we got here, R low to low is 36.6. Like the chance I am low now, going to low is 36.6. The chance if I am low, the chance to go to high is 63.4. If I am high today, then the chance to go to low is 40%, but the chance to go to high, from high to high, is 59%. 0.4. Now here, the return for low is negative 1.7%. The return for high is 0.017%. So R high, R low, R high, and this is beta, and this is alpha. Okay, so now the question is, what state I am now? I am in the low or in the high? Well, obviously, here is it. You can see here, this is your return, negative 0.0046. Is that a low or high? Well, you go to the data, and your average is 0.006. But the last observation was negative 0.004. So in the data here, which is this number, the last observation is less than the mean. Less than the mean, which means we are in the low state. Okay, now we understand where we are. You go to the leapfrog. Now the expected return. The expected return is the chance we are on a low, basically, right? So the expected return is low, we are on a low. So now I'm here. There is a chance I'm going to low again, which is this. So there's a chance here equal. So now I'm low. So what's the chance? It's this low multiplied by a return of low. And that's a return for low. Plus, there's a chance I'm going from low to high. From low to high, which is this, multiply of the return G7 of the return of high, which is, this is the return for high. Enter. Now, if you are in the high, then your formula is different. You're going to take the high 40 times high to low. So there's a 40% I'm going to low. And then plus high to high, 59%.4, multiply by that. So if you are in the high, then you're not going to take F14. You take F15. That 14 will be 15, and the G14 becomes the G15. Now, the current price, I don't know what's the current price of Amazon today. I need to go to Yahoo Finance again. 3,659. So 3,659. Sorry, 3,659. All right. Now the return next month, expected return is this. So next month we expect Amazon to be that's the return for Amazon we expect. This is in percent. It will be 0.4% up. This is the current price. So next month we expect Amazon to go to this price. So basically, if you bought Amazon, your profit, expected profit, will be equal to this minus this. Now, one more time, and I'm done, but I'm not going to keep talking the same thing over and over. Here you have a square root. There's a square root of something, square root of this. So what students do, they copy this and paste it here. No, there's a square root, okay? Square root of this number. So what I'm going to be watching if you follow up the square root or not. That's what I'm going to be looking. So please do that. So what's the inference? And the inference is if you buy Amazon, there is a chance that in average you're going to have about 0.47%, which is less than 1%. The price today at 360.59. The projected price is this, and that's your profit, $17. So now if you like this company, you buy it and you're done for next month if you're monthly. If you want to do the analysis annually, then you change this data from here. We take it monthly. Then you have to go to Yahoo Finance and get the data annually to convert that to annually. If you want to trade Amazon on a daily basis, you collect daily basis. So what we have in hand is if you do analysis for monthly, Amazon will go that much percent, and that's projected price, and $17 is your projected profit. That's it. We're done. So what's your homework? Your homework is pick a company, and I don't want you to do revenue or cost. Just do the return the same way I did it. Get the two moments, mean and standard deviation. Put them in a Monte Carlo. Do the simulation. Do some tests here to make sure you get that. And make sure in the video I can hear you. So test yourself, do a video for 10 seconds. Make sure your audio is good. And then after you get this data, you copy this data, you go to the leapfrog, you do it, RT -1. You get this inference, and that's it. So create a video about the company and project their price. And that's economic forecast. I taught you the most important two economic forecasts that we teach. These are at PhD level, but I simplify this to be at your level. But if you want to go more deep, this we can be not 2 states, can be 3 or 4 states. And the Monte Carlo, we can use the third moment in the Monte Carlo, the skewness, to make it different. So there's a lot of opportunities to grow from here. But for now, what I want you to know is to master these two models, to create a video and master this work, and from here, and then understand how to project. Now, if your company asks you to project their revenue for a different company, or the cash flow, or the cost, you put the data for the cost or the revenue, and then you calculate the change, and you put the change over here. So it has to be growth here. It has to be growth or a change in percentage. Thank you very much. And if you have a question, email me. Thank you.